So welcome to this WiseOwl tutorial on other things you can do with sequences. So we've looked at iterating over sequences, we've looked at slicing sequences, and now what we're going to do is look at some of the other things you can do. So here's what you'll learn in this tutorial. We'll begin by looking at joining and splitting strings in more detail. I promised we'd do this in a previous tutorial. And then we'll go on to look at partitioning text, which is an extension to splitting strings. We'll look at enumerating sequences so that you can see for a list what number each item is. And then we'll go on to look at mixed sequences, which is where we'll prove that you can put anything you like in a sequence, including another sequence. And then we'll look at unpacking them so you can get items out of them. We'll look at sorting and reversing lists, which I think is fairly self-explanatory. And then we'll look at adding and removing items in a list, which is also fairly self-explanatory. And finally, we'll look at shallow and deep copying and find that when you copy a list, everything isn't always as it seems to be. At the top right of your screen, you'll see an icon appear about now, and you can click on that at any time to see files I've used for this tutorial, and also to see any exercises attached to it. But, as always, I think that's enough of looking at me. So what I'm going to do now is vanish and hand over control to my faithful assistant Sven, who will guide you through the rest of this tutorial. So let's get started. So the first thing we're going to look at is splitting strings of text and rejoining them together again. I've got here a file called joiningandSplitting.py, and it contains a variable I've created called cats, which holds the names of the 6 current WiseOwl cats. And what I want to do is split this into a list. I can do that by creating a new variable, which I will call cat list. Seems a good name, doesn't it? And what you can do is take any string of text, and then you can use the split function. And the split function can take any string argument as a separator. You can see it says that there. So what I'm going to do is I'm going to use a comma as a separator. And what that should do is take the string of text and split it up into a list. Let's see if it's actually worked. If I then print out the list which I've obtained by running these commands, and then if I try running that, you can see it gives me a list. And you can tell it's a list because it's got a square bracket at the beginning and a square bracket at the end. What happens then if I want to rejoin them together with a different separator? So what I'm going to do is join the list back. The command to do this is considerably less intuitive, I think. So I'll create a variable called rejoinedList. And the way you do it is you start with a thing you're going to use as a joining character. So I'm going to use what's called the pipe symbol. You'll find it at the bottom left corner of your keyboard if you're interested. And I'm going to use that as a cement or a mortar to join all my bits of text together. It's not the obvious place to start, and I find it really hard to remember this command. I can then use the join function, and in brackets I can say which list or which sequence I'm using to join it. In fact, I'm choosing which iterable item, but that's not just another word for sequence, really. So I'm going to use my cat list that I created, and again I'll check this worked by printing out the value of my variable. So let's see if that worked. And you can see it's given me the same list back again, but with a different separator. Just for fun, you could reverse it. This is just a bit of revision from slicing. So what I could do is go to my list, and I could say, well, I'm going to start at the last item in the list. I'm going to go to the first, and I'm going to go one item back at a time. And what that will have the effect of doing is reversing my list. So I start with Agatha and end up with Annie. So as well as splitting and joining text, you can also partition it. And I've created a file called partitioning.py to demonstrate this. What I'm going to do is import the built-in sys module, and then we're going to print out sys.path, and what that will do is show me the current Python paths in Visual Studio Code. So if I run that, you can see, as in so many cases, it's actually returning a list of strings, each one being a separate path. Now, supposing I want to get at just the last bit of each path, so that, etc. To do that, I could firstly loop over all the items in the path. So I'm going to go back to my code, I'll set up a variable to refer to this. I'll call it paths. And then I'll loop over all the paths. And to do that, as always, I can type 4. I'm a bit wary about using the word path as a variable, so I'm going to call it p. So for each path, I'll just print it out for the moment, just to show you what's going to happen. So if I run that, I get my paths. Now what I want to do is pick out the bit after the last backslash. I could use the split function and pick out the last item in the list, and it would work perfectly well, but there's a quick way to do it, which is to use partitioning. So what I'm going to do is create a variable I'll call it last bit, and I'll set that to be, take the string of text contained in the path, and I'll partition it, and I'll use the backslash as a separation character, which I need to repeat because it's a special character. What that will do is divide my text up, each bit of text up into 3 different lines. And to show you this, I'll just print out the resulting list. So if I now run that, you'll see it's the principle's there, but it hasn't quite worked. What it's done for each line is split it not at the last double backslash, but at the first one. So what I needed to do is, instead of using the partition function, I needed to use rpartition. And personally, I think there's a bit of inconsistency here. I think it should have been called lpartition and rpartition, but maybe that's just me. So now if I run that program, you can see it's given me virtually what I want. It's given me the whole of the path up to the last backslash, and the bit after it. So that's what partitioning does. It splits any string of text into 3 parts. So to complete my program, what I could do is, instead of printing out the last part, I could just print out the last element in that. And to do that, I can use -1. Although I'm not actually sure I've shown you this, you can use this even if you're not slicing text to pick out the last item. So now if I run that, you can see it gives me the folder names I was after. So to illustrate enumerating sequences, I've created another file called enumerating.py, and I've copied my list of YSL cats to the top of it, including a command to split the cats and display the resulting list. And if I run that program, you can see it gives me a list containing the 6 cats. So firstly, there's a command or a function called index, which tells me which item something is in the list. I don't think it's that useful, but I thought I'd briefly show you it before we look at enumeration. So for example, supposing I want to say which cat is Neo. What I could do is print out the list, and I could use the index function to pick out a particular item. And what that will do is show me the number 1, because Annie's 0th item, Neo's the first item, etc. So when I run that, you'll see I get the number 1. But that's not that useful. What's often more useful is to be able to number each item in the sequence. And you can do that using the enumerate function. So what I'm just going to do is to comment out those 2 lines of code. And we're going to do some enumerating. It's cats with numbers. So far I've suggested that when you loop over the items in a sequence, you always do so using this syntax. And you nearly always do. But there is an exception to this rule, which is you can enumerate a sequence. And what that will do, as this excellent bit of help tells you, is it will return pairs. And for each pair, you'll have the count of the object from the start, defaulting to 0, and the actual item in the list. Because it returns 2 things, you need to capture 2 things. So what I'm going to do in here, between the for and the in, is put 2 variables, one of which will hold the number, and the other of which, in this case, will hold the cat name. The first variable when you're enumerating is always the one which gives you the number of the item. So what I can then do inside my loop is to print out the number and the name of this cat. So what I'll do is say cat number, and then I'll substitute in the number of the cat at the first placeholder, and then I'll put the name of the cat for the second. So as always, I can put format, and I can put the cat number as the first variable to go in there, and then I can put the cat name as the second. And if I run that program, it will virtually work. And the reason I say virtually is cat number 0 isn't Annie, cat number 1 is Annie. If you're using enumerate like this, what you tend to find yourself doing is just adding 1 to the returned index number. And then if I run that, you'll get the exact output that I was looking for. What I want to do in this session is show you two things. I want to show you what packing sequences means. But what I also want to do is show that a sequence, a list, a tuple, whatever, can contain objects of lots of different type. So what I'm going to do is create an arguably misnamed variable called useful info, and it's going to hold three things. I'll make it a tuple. So the first thing it will hold is the Lithuanian long jumping record, or record holder. Now I've looked this up on Wikipedia, so I believe it's right, but apologies if it isn't. I'm going to hold this as a list. And I believe he's called Povilas Mikolaitis. I have no idea if that's pronounced correctly, so my apologies to Povilas if I've mispronounced his name. The sport he was in was long jump, and he set his record, according to Wikipedia, in 2011. The next item I'm going to add to my tuple is going to be the number of baked beans eaten in 3 minutes with a cocktail stick. And again, I'm reliably informed by the internet, in this case, that it's 159 set by a comedian. And the final thing I'm going to store in my list is going to be our cats and the cat. I'm going to store this as a tuple, so I've got one tuple within another, and they are, as you probably know if you've been watching this series of tutorials, Annie and Neo. So tuples and lists really can contain anything. What I could then do is I could list out all these items. So as with every other tuple or list or sequence, I could say for every item in the list, print it out. And I'm going to list out not just the item itself, but I'm also quite curious to see if it's kept the type of it. So I'm going to print out the type of it as well. Now, if I run that program, you can see it tells me that the first thing I put in the tuple was a list, which I knew because it was in square brackets. The second thing was an integer, which I kind of would have guessed too. And the third thing was a tuple. You can even have tuples within tuples within tuples if you want. There's no limit, as far as I know, to how far you can go down this rabbit hole. Whether it be a useful thing to do, I'm not so sure. Now, having created my tuple, what I can also do is unpack it. So what I'm going to do is create 3 variables to unpack my, in this case, my tuple. The first one I'll call Povilas. I would like to think this is the first variable ever created on the internet called Povilas, but who knows? My second variable I'm going to call baked bean. And my third variable I'm going to call cats. And what I want to do is assign each of the items in the tuple to each of those variables. And there's a very quick way to do this called unpacking. What I can do is just type in the name of the list or the tuple and press return there. And to prove this has worked, I now need to actually display the values of my variables. So to do this, I can print out, and I'll do it in a different order just to prove that it really has worked. So I'll print out cats, and then baked bean, and then finally, I'll print out the legendary Povilas. So if I run that program, you can see it's given me the 3 bits of information I asked for at the end in the order: a list of cats, the baked bean information, and the information about the Lithuanian long jumper. You have to be a bit careful with this that you count correctly. So let's suppose I thought there was a 4th variable, which I called, X, and I tried running this. How can you squeeze 3 items into 4 variables? And the answer, of course, is you can't. Not enough values to unpack. Expected 4, got 3. An excellent error message. And likewise, it works the other way around. So supposing I added to my tuple at the top a 4th item, if you like, which I'll put as 42, and then I run my code, I'm now trying to put 4 bits of information, but I've only assigned 3 variables. So I could just use the first 3 variables and then discard the 4th item, but that's not what it actually does. It gives you an error message and says, I've too many values to unpack. So that's what unpacking is. The problem is it's only really going to become useful once we start reading in things like SQL Server tables or CSV files. But I thought I'd show you to this time because it seems to belong naturally with everything else to do with sequences. I've created a file called sortandreverse.py, and it contains a list of all of our cats. And the name of the file should give you some indication of what we're about to do. Sorting is relatively easy, but it always catches me out. The first thing to notice is this is a list, it's not a tuple. Had it been a tuple, I wouldn't have been able to sort or reverse the order. Because it is a tuple, I can sort it. And to do that, I can say cat.sort, and then in brackets, I can specify how I'm going to sort it. The main arguments you can use are the key, if it's something with more than one value in, but this is a single dimension, so there's no key needed. And whether I want to reverse the sort order, just for the hell of it, let's do that. Let's put reverse equals true. The other thing to watch out for with the sort method, going back to that, is what it returns. It says at the bottom, or sorry, just underneath that it sorts the list in ascending order and returns none. Now what that means is that while that command will work, and let's just prove that. So I print out my newly sorted list of cats. You can see I get the same cats, but in reverse order, alphabetical order. This command won't. And every time I try to use this, I get caught out by this. Although you would think that would sort the list of cats and store it in another variable, it won't. Do you remember I said that the sort returned none? So when I run this, I just get the word none. It doesn't hold anything. So sorting works in situ, if you like. It works in a list without creating another. And reversing works exactly the same way. So what I'm now going to do is reverse this list. So I can say cats.reverse. And this time, there's nothing I can do with that. It just reverses the list. So now if I print this out, I will get a list of all the cats, but back to my original, well, not my original order, but in alphabetical order. And of course, I could have done this without reversing it by just changing my reverse equals false there, true to false, or I could have just missed that out because the default sort order is just to do things in alphabetical order or numerical order, ascending. So that's how you can sort and reverse lists. What we're now going to do is look at adding and removing items from or to lists. And the reason I say lists and not tuples, strings, or ranges is because lists are the only sequences which are mutable. So they're the only ones you can change, basically. So what I'm going to do is begin by creating a list. I've created a file called adding and removing items.py. And the list I'm going to create is going to hold a list of all the wizards in the Harry Potter books or films. I'll set it as an empty list to begin with. Now, if you've never heard of Harry Potter, I really wonder what desert island you've been living on for the last 20 years. Everyone surely has heard of him. I'm going to add a couple of wizards. So the first one I'll use the insert method, and I'll add Harry. Before I add the second one, what I'd like to do is just prove to my own satisfaction that this has worked. So I'm going to print out the result of my list. And I think it's going to crash. And the reason is that when you insert an item in a list using the insert method, you need to specify where it's going. So I'm going to add it before the 0th item, i.e. at the top of the list. And then I'm going to add Hermione, and I'm going to add her at the 0th item as well. And what that will do is it will push Harry down. So when I print out the results, you'll get Hermione as the first item in the list and Harry as the second one. So another way to add an item is to append it. In this case, him, because it's going to be Ron. So what I can do is use the append method. And the advantage of using the append method is because you know you're adding it to the end of the list, you don't need to specify an index number. So I'll just add Ron in. Quickly run that to check everything's going okay. It is. Instead of adding single wizards, what I can do is add a whole batch of them. So what I'm going to do is create a list of all the Death Eaters. So So this is where my Harry Potter knowledge will get a bit shaky. But I'm going to go for, I'm pretty certain Lucius Malfoy was one. I would have thought Barty Crouch was one too. Who else might there be? Bellatrix Lestrange. And I think I'm leaving my comfort zone after that, so I think that will do. Now what I want to do is add these on to my list of wizards. And to do that, I need to extend my list. And you can do that by taking the wizards list. And you might have thought you could use the append method I've just shown you. But the append method will actually only add a single item on. Now, if that single item happens to be a list, so be it. When I run that, you'll see I have 4 items in my list: Hermione, Harry, Ron, and the list which contains a list of Death Eaters. So that wasn't quite what I wanted to do. Instead of using append, you can use extend. And what extend will do is add all the items in the second list onto the first one, which is exactly what I want to do. So if I run that, I get my 6 wizards. 3 good, 3 bad, basically. So that's how you can add items to a list. You can also remove them. I think it's time to remove Barty. He was a horrible person. So we can do that by applying the remove item. And then in brackets, you can specify which item in your list you want to remove. I want to get rid of Barty. And when I run this, you can see I've got my Barty-less list. Also use something called the pop method to remove an item from a list. And there's 2 differences with this. One is that you specify not the item you want to remove, but its position. And the other is you get a reference to the item at the end of it. And let me explain what I mean by that. So I'll create a variable called Bella. And what I'll do is take the list of wizards, which still contains her, don't forget, and I'll pop the item in the last position. And what that will do is not only remove Bellatrix from the list, but also store her name in this variable. So just to reassure you that that's actually worked, I'll print out the name or the value of that variable. And when I run that, you can see I get Bellatrix's name, and then I get a list with her no longer in. So popping removes somebody from a list, but also gets access to their item. And the final thing I can think you can do to a list is you can clear it. So you can remove all the items from it. And the way you do that is to clear it. And because that's the method, I need to put open and close brackets after it. So the net result of all my long adding and removing items is actually now going to be a completely empty list because I've just removed all of the items from it. So those are all the things you can do to add and remove items to or from lists. We'll be using them for the rest of the tutorials on this course, so I just wanted to make sure you would cover them in this one. So what I want to do now is look at how you can copy a list, which you might think would be a fairly easy topic. I've got a list of all the cats, the Wise Owl cats. We're familiar with that by now. And what I want to do is create a copy of it. So in my naivety, I'm going to create a copy just by creating a new variable. I'll call it copycat, if you'll excuse the pun, and I'll set it equal to the first one. What I'll then do is I'll make changes to each of the 2 original lists. So let's, for example, add in a cat for the first list, and I think I'll buy a new cat called Tiddles, which is a great name for any cat. And for the second list I've created, I will remove Annie. So what I now want to do is have a look at the effect of that by printing out my 2 lists. So I can print the results, and I'll print out my first list of cats, and I'll print out my second list of copycats and see what the effect is. So my guess is you expected to see what I always expected to see, which is that the first list would contain 7 cats, the original 6 plus Tiddles, and the second list would contain 5 cats, the original 6 minus Annie. But that's actually not what you get at all. When you run this, you get the same list twice. To see why this happens, I'm going to add in a couple of extra printouts. So I'm going to print out the IDs. So you can use the ID function to print out the internal ID of where something is stored in memory. So I'm going to print out the ID for both my cats, original cats list, and for the copied copycats list. And if I run that program, what you'll see is the ID is absolutely identical in each case. What this means is that this statement doesn't do what you might have thought it did. Instead of taking a copy of it, all it does is means we have now two ways to refer to the same thing. It's as if I said I'm called Andy, but at weekends I want you to call me Susan. I've got two names, but it's still the same person. And if you make a change to me, that's going to affect both of the two ways you can refer to me. Both Andy and Susan will change. What I really wanted to do was, instead of doing that, I wanted to copy my list. So that's what we're going to do now. So to copy a list, you can just put .copy at the end of that. If I run that program, you can see it solved my problem. Not only have I got a different ID for each of my two lists, but they've been independently changed. So I've got what I expected to see at the beginning. My first list contains all the original cats plus Tiddles as well. And my second list contains all the original cats minus Annie. And you might think, well, that's an end to it. What I'm now going to do is show you it's not quite the end of the story. I think this is of marginal benefit, what I'm about to show you, but by all means, watch on if you wish. It's called deep copying. I've created a file, and I'll include it with the files with the tutorial, which contains a slightly more complicated variable. So it contains a list of cats, and for each cat, instead of holding just a name, I've got a list of the cat's name and the cat's owner. And what I've done is I've copied that list, and then I've made a change only to the first list. I've taken the first item in the first list, which is this line here. Sorry, the second item, index number 1. And what I'm doing is changing the first item within this list to Sprout. And the reason I've done that is when we bought Neo, originally he was going to be called Sprout. I'm not quite sure what happened there. So I've shown you the copy works. So it's rather pointless printing out the IDs and the lists, because we know it's going to show different things for each list, isn't it? Well, let's find out. So when you print that out, sure enough, the two lists have got different IDs, but the change has been made to both of them. What on earth is going on? The reason is, when you have a list which contains other lists and you do a copy, instead of copying absolutely everything, it just copies things at the highest level of the hierarchy. What we need is something which will not only copy everything at the top, but it also burrow down into any sublists and copy those too. And that's called deep copying. And the way to do that is to import the copy module. Then to change this line, so from the copy module, it uses the deep copy command on the original list. If I now run that program, you can see it's made my change. The first list has Neo called Sprout, and the second one he's still called Neo. Deep copying is the sort of thing which people on the internet get very excited about, but I suspect you could, in your entire Python career, you'll probably never need it, but at least I've included it there for the sake of completion. And that really completes everything you can do with manipulating lists.